This first effect demonstrates that the dynamic particle system framework provides methods to add, update, and draw particles. These particles have some built-in particle system interface properties, including position, velocity, and color. By exposing the emitter to the client as a particle system interface parameter, the client can specify the emitter's position and orientation. By allowing them to update these PSI parameters at runtime, the client can interactively control the position and orientation of the particle system, including rotating it around a pivot point, as is shown here. Here we see the use of particle system events, where timed particle system events are used to turn the emitter on and off at different intervals. This effect shows particles interacting with an object in the environment dynamically at runtime, where in the first pass the particles are repelled from the orb, and in the second pass they are attracted to it. This effect also shows that interaction between particles and the environment is possible using DPSF. In this example, the particles are specified to bounce off of the floor. This effect also demonstrates that this interaction can be turned on or off at runtime through the use of a PSI parameter. To accomplish this effect, a new PSI property called bounciness was specified by the client. By adjusting this property with a PSI parameter, the bounciness of the particles can be interactively controlled by the user at runtime. In this effect, smoke particles are generated by fire particles approaching the end of their lifetime. The probability that a fire particle will generate a smoke particle is based on the smokiness PSI parameter. This effect also shows that the render properties of a particle system may be adjusted at runtime. Here we see interactions between particles in the same particle system. In this effect, a single particle is controlled by the user through the use of the mouse. The other particles in the particle system are then either attracted to or repelled away from this particle. The user is able to switch between attraction and repulsion by clicking the left mouse button. Here we also see that friction may be applied to particles at runtime. In this effect, friction is applied to, or removed from, particles at runtime by clicking the right mouse button, interactively changing the particle behavior. This effect also demonstrates that particles do not have to die and be removed from the particle system. This is accomplished by setting the particle's lifetime to 0. In this effect, we see particles being controlled deterministically, where the particles spiral around the y-axis before coming to rest at their final positions. This effect also demonstrates that each particle may be assigned texture coordinates, allowing the particle to be represented on screen as only a portion of the particle system's texture. The complete image composition is accomplished by creating additional particle properties in the particle class, including the position and orientation that the particle should have in order to make up the final composite image. This effect demonstrates that animated particles may be created using DPSF. In this effect, a particle's animation is played faster when the particle is traveling upward and slower when it is traveling downward, giving the impression that the butterflies have to flap their wings more in order to increase altitude. This last effect demonstrates that static particles may be achieved using DPSF, where a static particle is a particle whose movement and behavior over a span of time is drawn in a single frame.